Okay, how we doing? Anybody need more time to read through that? If you didn't quite get all the way through the procedure, that's okay. I wanted you to have a little bit of the background and at least start reading through the procedure so you kind of had some idea what was coming up. So today we're doing a respirometer lab. We're going to put together a device that allows us to measure the rate of cellular respiration. And the two things that we're going to be testing in this lab, we have just some plastic beads. These blue beads are just plastic. Kind of as a comparison, because there are lots of other things that can affect the volume of gases like air, which is what we're measuring here. And so that's to make sure that there aren't any changes in temperature or air pressure or anything like that that's going to affect our results. And then the thing that actually should be doing some cellular respiration are these peas right here. I'm not sure if you can see that. These are germinated peas. Which what that means, when you buy like beans or peas that are dry in the grocery store, they're dormant, right? They're not about to grow. But if you put them in the soil, or in this case, I just gave them some moisture and some warmth. I put them on wet paper towels and soaked them for a while. They germinate, which is they basically kind of wake up, they start doing cellular respiration. And this one actually, I know it's really hard to see on there, it actually has this little white thing sticking out that's about to become the roots. And so it's basically starting to wake up and grow. And so that's what it means to say we're using germinated peas. They're kind of activated and starting to grow. So we're going to assemble this setup, and then I'll give you some time in breakout groups to talk about it and answer those pre-lab questions. I have already measured the volume. If you looked in the procedure, it said you need to have the same volume of the peas and the beads. I did that beforehand, so that part's done. The main point of that is they're not the same size, and so we want to make sure the volume of cells or of material that we're testing is equivalent in both of our containers. So that's why we did that. I also put the cotton balls in the bottom of these two test tubes, but I haven't put anything on them yet. So if you're kind of following along in the procedure, we're starting kind of with step 3. These vials do have washers glued on the bottom that makes them heavy so that they sink. And so the next thing we're going to do is we are going to add some potassium hydroxide to each of those cotton balls, just 1 milliliter. This is actually a really important step because remember what we're measuring here is the volume of gas in the respirometer. But if you think about how cellular respiration works, it does produce a gas. It produces carbon dioxide. It also uses oxygen. And so if we just left this as it was without this step, the amount of oxygen that was used would be offset by the amount of carbon dioxide produced, right? So it would end up pretty much overall the amount of gas would stay the same because we can't tell from these respirometers whether the gas in there is oxygen or carbon dioxide. The volume would just stay the same. And so what that potassium hydroxide does is it absorbs the carbon dioxide that's produced and turns it into a solid that will just accumulate down there on that lower, on this lower cotton ball that has that potassium hydroxide on it. The carbon dioxide will kind of be collected down there in a solid form. So the only gas change that we will be seeing is due to the oxygen that's being used. Does that idea kind of make sense to everybody? So we're kind of absorbing the carbon dioxide as quickly as it's produced. So the only volume change that we see will be due to oxygen consumption. So then we put that other cotton ball on top just because that potassium hydroxide is corrosive. And so we don't want it actually in contact with our peas or our beads. So that second cotton ball is just kind of a layer in between. And then we add the peas to 1. So you can see we've got our absorbent cotton ball with potassium hydroxide, then a rayon cotton ball on top of that, and then a bunch of peas on top of that. And we'll do the same thing with the beads in the other one. And there are more beads because they're smaller. And remember, the thing that we're keeping constant here is the volume of the substance that we're testing. So same thing, cotton ball with the potassium hydroxide, another non-absorbent cotton ball just to block it, and then the beads on top. Next, we are going to insert the pipette that we're going to use to measure. So you can see kind of, I know you can't read it, but you can hopefully see that there are measurement markings on here so that we can measure the volume of gas in this pipette. Once we get this all set up, one end will be sealed off with some food coloring. The other end we are going to seal off by putting it through a rubber stopper like that. Just the very last little bit. We are going to use a little bit of petroleum jelly, which is basically just like Vaseline, to make sure we have a good seal. You can see that's kind of loose. It kind of slides up and down in there, and we don't want air getting through that crack. So I have just a little bit of petroleum jelly. It's basically Vaseline that we're going to put around the top to make a good seal so that water does not get in there and gas does not escape around that pipette tip opening. So we're just going to seal that up there and then insert that into the top and make sure that it's pushed way, way down here. There. So that is kind of what our assembled respirometer looks like. I am just going to put together the other one real quickly. Make sure that's sealed around the top. And insert that in there, nice and tight. Okay, so we have our two respirometers set up there. I'm just double checking so I don't skip any procedure steps in here. So the next thing we have to do is put these into a water bath. So if you get easily seasick, close your eyes for a minute. I'm going to spin the camera around so you're looking at the water bath instead of at this stuff. Ready, set, go. All right. So here is my water bath. This has just been sitting in my classroom since yesterday so that it could come to room temperature. Room temperature in this classroom apparently is about 18 degrees. The last thing I'm doing here is I am just putting a couple of steel washers on the top. That's just to help these sink because we don't want them floating. We want them to sink at least a little. And the coral is in there simply so that they don't slide backwards all the way into the water quite yet. We want the vials mostly in the water, so I'm going to slide them back a little, but we don't want them completely into the water. So the next step in the procedure says that these need to equilibrate to the temperature of the water for 10 minutes. So I am starting a timer right here. The reason for this part is that a gas will change volume if it changes temperature, which should kind of make sense to you, right? If you heat up air, the molecules are going to move faster and then they're going to spread out and take up more space. And we want to make sure that the changes we measure are not due to changing temperature as this equilibrates with the water, but just due to the process of cellular respiration. So it needs about 10 minutes to equilibrate. After that, the next step is that I will add a drop of food coloring into this tip of each of these pipettes. And the food coloring will go in there. That's basically what we're using as our measure mark. What that does is it seals off this end, and then it allows us to measure how much gas is trapped inside of there. And as cellular respiration happens and oxygen is used up, the amount of air inside of that should decrease, so that food coloring should kind of get sucked down further and further if cellular respiration is happening. So all of this equilibration part takes about 15 minutes. So what I'm going to do is I'm going to put you into your breakout groups for 15 minutes. During this time, I want you to talk through the procedure and see if you have any questions. And you can work on answering the pre-lab questions in your lab document. And then in 15 minutes, we'll come back and I'll show you kind of what the setup is like at that point, and we'll talk about the data collection part of this. And you can also ask me any questions that you have. Does anybody have any questions right now before I throw you out into breakout groups? All right, then give me just 1 second to pull this back up. All right, so here you go. Come back and ask any questions you have. I will see you in 15 minutes.
Miss Ness-Deden?
Yeah.
Okay, so I should have texted them before, but I assumed that since at the beginning of to try this year, we picked all our notes for the rest of the year, that we would have everything that we needed. And I texted someone like earlier, or like 10 minutes ago, and they said that you said it in a recent post that we would have more pickup, and I never did. So is there any way that I could do this on,
All right, so I think everybody's back. So I'm going to show you a little bit what I did while you were gone and talk a little about data collection. And then you'll have a chance to ask any questions. And if your group didn't quite finish, you'll have a chance to go back into those breakout groups in a little bit if you want to. But I wanted to kind of show you what I have done while you were gone. So this equilibrated for 10 minutes, like I said, so everything could come to temperature. And then I added a drop of red food coloring, and I'm going to try and put my phone flashlight on here so you can see it a little better. So hopefully you can kind of see that there is some red liquid in the tips of each of the pipettes here. What that does is it blocks off that end, so water can't go in. There's gas. The air that was in there is trapped within that respirometer now. And it also gives us a way to measure. So what I'll be measuring is the location of the lowest end of that red food coloring every 5 minutes as we go through here, starting in just a second. It is actually time to record my first data point that had to equilibrate for 5 minutes, and we just got there. So in the data table, there are 3 things that we're going to record each time. We'll record the temperature, which this water bath is at 18 degrees Celsius. That apparently is room temperature in my classroom. And then our respirometer readings. Let me see. The one with the beads in it is at 0.78. And the one with the P's in it is at exactly 0.8. So 0.78 for the beads and 0.80 for the P's. So what's going to happen now is that I'm going to continue taking those measurements just like that, measuring the location of the lowest end of the food coloring every 5 minutes for the next half an hour. As I do this, you do not need to sit here for another half an hour and watch. I'm going to record the data, and then I will post the data probably in the homework on the respiration lab that you were looking at. I'll put it in that homework post so the data is right there and available for you. What else was I going to say about that? I think that's about all. And so remember, as this volume changes, it's equalized to the temperature, so it shouldn't be changing due to temperature. Both ends are sealed, so no air can go in or out anywhere else. The only change in volume here should be if oxygen is being used up due to cellular respiration. Does anybody have any questions about the setup or about any of the pre-lab questions? Was there anything your group was wondering about? Because other people probably have the same question. So go ahead and unmute if there was anything you had questions about. We all good? All right, obviously I will be here for another 25 minutes, so I will stay on the meet as long as anyone else is. I am going to open the breakup rooms, or breakup, sorry, I've heard that mistake made by other teachers. I've never said it until today. Breakout rooms. I'll open those up again if you still have pre-lab questions or things that you need to finish working on. Otherwise, once the data is posted, you do need to make a graph of this data. Please either make it on a computer or on graph paper, which you should have some at home. If you do it on paper, you have to take a photo and upload it with your assignment. And then there are also some post-lab questions. This whole lab is due before Tuesday morning, so like by Monday night. You can stick around and ask any questions today. You're welcome to ask questions about it tomorrow at the live session as well if you start on it tonight and then you have some questions. I'll probably have the data posted before 3:30, so it'll just take me another 25 minutes here to collect the data, and then I'll post it in about half an hour. All right, so I'm going to open those breakup rooms again. You can either go back into those rooms if you still have work to do with that group, or you can just log off for the day, and that's it. Anybody have any more questions right now? All right, I'll open those rooms back up. You can either jump in there, or you can stick around and ask me questions, or just sign off for the day, and I'll see you tomorrow.
I have a question about the pre-lab question.
Yes.
Can you explain number 4?
Number 4 was the one saying what happens if you don't let the temperature equilibrate, right?
Yeah.
So, like we said, if you look in the background information, it actually gives an equation that it calls like the gas laws that talks about pressure and volume and temperature and kind of how all those things are related. You don't really need to know that equation at all, but it's in there so that you realize that volume of a gas is also affected by temperature, which should kind of make sense, right? If we take these things right here and if we heated these up, the air molecules in there would start to move around faster, which means they'd bump against each other and they'd take up more space and they'd push the food coloring this way. And so our volume measurement would change if the temperature was still changing. And same thing, if these weren't at the same temperature as the water, if they were still cooling down, as those air molecules slow down, the volume would be decreasing, but it wouldn't be because of respiration. It would just be because of that temperature change. Does that kind of make sense?
Yeah.
Okay, so we have to let it equilibrate and get everything to the same temperature first so that we know the only thing changing it is respiration.
Okay.
Any other questions?